Today we are going to be trying to show that two triangles are similar to each other, or to prove that they are not similar to each other. Last time when we talked about similar figures, in order to decide whether or not the shapes were similar to each other, we were testing all of the corresponding angles. And in order to have similar figures, we had to show that every single set of corresponding angles was congruent. And we also had to show that every single set of corresponding sides was proportional. If you're looking at triangles, there are some shortcuts. You don't need to know information about every single set of sides and every single set of angles. You only need to know some information about some of those things, and you can prove for sure whether or not the triangles are similar. There are 3 different tests for similarity. We're going to go through the 3 different tests separately, and then we will look at some problems where you have to decide which test to use, and then decide whether the triangles are similar. The first test we're going to use is called the angle-angle similarity postulate. So a really good way to know that you're dealing with angle-angle is you won't have information about how long any of the sides are. The only thing you'll have information about are the angles. So what the angle-angle similarity postulate says, notice it only mentions 2 angles. So it says exactly what it sounds like. It says that if 2 angles in one triangle are congruent to 2 angles in another triangle, then the 2 triangles are similar. So in this drawing right here, I have 2 sets of angles that are marked as being congruent. Angle J and angle X both have 1 mark. So if angle J is congruent to angle X, I'm also told that angle K and angle Y are congruent. They both have 2 marks. So, and angle K is congruent to angle Y, then I don't need to know anything else about the triangle. I don't need to know about the other angle. I don't need to know how long any of the sides are. If I can show that I've got 2 sets of congruent angles, that is enough for me to say these triangles are similar. So I can write a similarity statement. Remember, it doesn't matter what order you name the first triangle in, as long as the order of the second one matches. So I'm going to name the first triangle, triangle JKL. And remember that the symbol for is similar to is just a single squiggle. And it will be similar to triangle X, Y, Z. And that order is important. J and X both came first because those were congruent angles. K and Y are in the same place because those were congruent angles. And L and Z both came last because those are congruent angles. So this is what the postulate says. Now we're going to look at a couple of problems where we can use angle-angle similarity to decide if 2 triangles are similar. There are a couple of things that you need to remember. The first one is that the angles in a triangle add to 180 degrees. So in order to figure out if the triangles are similar, we need to figure out whether we have two sets of congruent angles. So if I look at these two triangles right here, I can see that I do have one set of congruent angles. Angle B and angle R are both 78 degrees. So angle B is congruent to angle R. Then in triangle ABC, I have a 63-degree angle, and in triangle PQR, I have a 39-degree angle. So those obviously are not congruent, but I also have an angle that isn't labeled in each triangle. And because I know the angles in a triangle add to 180 degrees, I can figure out how big that angle is. So if angle C turns out to be 39 degrees, the two triangles would be similar. So what I'm going to do is I'm going to figure out how big angle C is. I'm going to add together the two angles I know. So that gives me 141 degrees. Subtract that from 180 degrees. And that gives me 39 degrees. Now I could of course have done the same thing to figure out angle Q, but I really don't need to because I only need two sets of matching angles. So I have just determined that angle C is congruent to angle P. On your homework, you're going to be asked to list all of the sets of matching angles that you know and show how you know. So this work right here would have shown how I figured that out. So I have shown that I've got two sets of congruent angles right here. So that's enough to explain my reasoning. So now I know they're similar, I can write a similarity statement. So I know that triangle A, B, C is similar to, and I've got to go in the right order here. A is the 63-degree angle. Well, that must be angle Q right here. So triangle Q. B is the 78-degree angle. So that would be angle R. And C is the 39-degree angle. So that would be P. So triangle ABC is similar to triangle QRP. You may see problems where you have overlapping triangles. One thing that really helps when you have overlapping triangles is to draw the two triangles separately. So I have taken this diagram and I have drawn the two triangles that make up the diagram separately. I have triangle GLH and triangle GKJ. So both of them had a 41-degree angle, and I've labeled that. So I definitely know that I've got one set of congruent angles. I have angle H is congruent to angle J. But in order to have angle, I need to have a second set of congruent angles. So as I look at these two triangles, I have to think, well, are there any other angles that are the same in both triangles? And it may not be completely obvious until you think, oh, wait a second. This angle right here is exactly the same angle in both triangles. So angle G is congruent to angle G. So this one was given to me. And this one is literally the same angle. So because I now have two sets of matching angles, I know that the two triangles are similar now. So I can write a similarity statement. I'll name the first one triangle LGH, and that will be similar to triangle KGJ. Again, make sure that the order matches. So this one asks me to look at this diagram and fill in some blanks. So it wants to know angle B is congruent to what? So if I look at the diagram, angle B has one little mark right here. So over here, angle D also has one mark. Then it asks me about angle ACB. ACB, that's this one. And it wants to know an angle that is congruent to. So think back to 9.1 and remember that angles that are across from each other in an X are always congruent. So that angle would be the same size as this angle, which would be angle ECD or DCE, doesn't matter which order you name it. And those angles are called vertical angles. I can't read my E very well there. I'm going to try to fix that. So now it wants me to write a similarity statement here. Triangle ACB. So that goes from the unmarked angle to the one with 2 marks to the one with 1 mark. So that would be similar to triangle. Unmarked angle would be E. The one with 1 mark, no wait, the one with 2 marks is C. And the one with 1 mark is D. Color coding is useful. And E's just do not look very good today. And why are they similar? They are similar by the angle-angle similarity postulate. What is the scale factor? So the scale factor, we need to find a fraction made up of one set of matching sides. So as I look at this, I've got a 6, that's between the unmarked angle and the one with 1 mark. Well, over here I've got Z, the one with no marks and the one with 1 mark. In order to get the scale factor, I've got to know both sides. So I can't do that one because it's got the Z. But here I have the 9. That's between no marks and 2 marks. And I've got a 6. No marks and 2 marks. So because I know both of those numbers, I can use those to make a scale factor. 9 over 6 equals 3/2. So what that means is that all of the sides in triangle ABC are 3/2 or 1.5 times as long as the sides in triangle ECD. So if I want to know a side in triangle ABC, I could take the side over here and multiply by 1.5. Or if I want to know a side over here, I could divide the matching side by 1.5. Or I can set up a proportion problem. So let's go ahead and fill in the blanks on the proportions. So I'm going to kind of color in my matching sides here so we can see. So between no marks and 1 mark matches up with no marks and 1 mark. Between 1 mark and 2 marks matches between 1 mark and 2 marks. So I can see which sides match up now. All right, AB over DE. So those are my pink ones. That's not pink. AB over DE equals AC over question mark. So which side matches AC? Well, CE does. Okay, then I have numbers plugged in for this. So AB was 6. DE was Z equals blank over CE was the 6. Sorry, I'm messing up the colors a lot. So AC, the blank here, is the 9. We have 6 over Z, pink over pink, 6 over Z, pink over pink, equals green over green, 9 over 6. So then I just need to solve the proportion. So cross multiply. So 9 times Z is 9Z equals 6 times 6 is 36. Divide by 9. And you get Z equals 4. Now there are other ways to get that Z equals 4. Some of you have probably figured out other ways to use the scale factor. The scale factor was 3/2. You could have figured out that you could divide each of these numbers by that scale factor to get there. That is another option for you if you prefer to think of it that way. So to get from the bigger one to the smaller one, divide. To get from the smaller one to the bigger one, multiply. That is one other thing you can do if you didn't like setting up the equation. So the next test we're going to talk about, you are not going to know any information about the angles in the triangle. You won't know how big any of the angles are or if any of them are congruent. But if you look at this example down here, all of these numbers are outside the triangle. They're telling me how long the sides of the triangle are. So in this case, if you don't know anything about the angles, but you know how long the sides are, you're going to be using what we call side-side-side similarity. Side-side-side similarity says if the sides of one triangle are proportional to the corresponding sides of the other triangle, which means that if you make fractions out of matching sides, all 3 fractions simplify to the same thing, then you have similar triangles. So, for example, if I make a fraction out of the 2 red sides here, AB over DE, if that fraction simplifies to the same thing as the fraction I can make out of the blue sides, BC over EF, and that fraction simplifies to the same thing as the fraction I make out of the green sides, AC over DF, then triangle ABC is similar to triangle DEF. Now all three fractions have to simplify to the same thing. It's not enough for two of them to. In order to make sure that you make fractions out of the right sets of sides, go for the shortest sides, the longest sides, and the medium sides, the middle length sides. If you do that, then you won't make a mistake. So here I've got three triangles, and I want to know if there are any triangles in this set that are similar to each other. So first of all, I am going to look at the three triangles, and I'm going to highlight the shortest side of each one. And I'll do that in pink. And I will highlight the middle length side of each one in green. And I will highlight the longest side of each triangle in blue. So if any of them are similar, the matching colors will be the matching sides. So smallest sides will match, middle length sides will match, longest sides will match. If you do that, that's really going to help you keep track of what's going on. So first, I will look at these two triangles on top. So first, let's look at triangle JGH and triangle, let's see, to name that, I went across the blue side and then the pink side. So this would be triangle CAB to go across the blue and then the pink. So first, let's test the shortest sides. So my shortest sides, it doesn't matter which triangle goes on top of the fraction as long as you put the same triangle on top of all the fractions. So I'll do the smaller triangle on top. So let's do 8/10. So go ahead, get a calculator if you need help simplifying that fraction. Both of those numbers can be divided by 2. That simplifies to 4/5. So if the other fractions simplify to 4/5, then they're similar. If they don't, they're not similar. So let's take a look at the middle sides. So the middle length side on the smaller triangle is 10, and on the other triangle is 15. Those can both be divided by 5, that's 2/3. Well, 4/5 and 2/3 are different. So if these are different, then the triangles are not similar. Okay, so these two triangles are not similar because 8/10 and 10/15 are not the same thing. So let's try a different pair of triangles. Let's try triangle ABC and triangle, let's see, I went across the pink and then the green. So DEF. So let's start with the shortest sides. So I'm doing this 10 right here, that shortest side over this shortest side. So 10/6. Those can both be divided by 2, so that gives me 5/3. Then let's do the middle sides. So I am doing this middle side and that middle side. So 15 over 9. Those can both be divided by 3. That gives me 5/3. Let's try the longest. So this longest side and this longest side, 20 over 12. Those can both be divided by 4. 20 divided by 4 is 5. 12 divided by 4 is 3. So look, all three of those are the same. 5/3, 5/3, 5/3. That means these two triangles are similar. Triangle ABC is similar to triangle DEF by SSS similarity. Now, you could test JGH and DEF, and they would not be. All right, there is one more test for similarity. This one, you will know something about one angle and something about two of the sides. And you can kind of look at it, if you see in the diagram, these blue ones that are labeled, those are sides. The red mark that's marked is an angle, and the green one that's marked here is a side. Notice that the angle is between the two sides. So what you need to know is you need to know that you have one angle that is congruent. So here, angle X and angle M have to be congruent. And the two sides that surround that angle have to be proportional, just like in the test we just did. So it has to be the angle between the two proportional sides in order for it to be side angle side. It can't be this angle down here, Z and P, or Y and N. It has to be the angle between the two sides that are labeled. So let me write this up. So this says that if two sides of one triangle are proportional to two sides of another triangle, which means that if you make fractions out of the matching sides, xz divided by mn will be the same thing as xz divided by mp, the blue side over the blue side, will simplify to the same thing as xy divided by mn, the green side over the green side, and that angle between the two, angle x and angle m, are congruent, then your two triangles are similar. Let's look at a few examples where side angle side would be appropriate. This first one is a little bit tricky because it involves overlapping triangles. So again, the first thing I recommend that you do is to draw the two triangles separately. I've drawn my two triangles, now I'm going to label them. So the smaller one is triangle WVZ, and I know that the side on the left is 8 units long and the side on the right is 10 units long. The bigger triangle is triangle XVY, and be careful, I want to know how long the entire side is. So if I look at how long is this whole thing, well, I need to add the two pieces together. I need to add 4 plus 8. That's going to give me 12, not 4, 12. So I want to add the two together. I want to know the whole side. And this whole side, 10 plus 5, that's 15. Now I've got two sides for each triangle. Do I know any angles that have to be the same in the two triangles? Remember, anytime you have overlapping triangles, there will be one angle that is the same in both triangles. This angle right here, angle V, is the same angle in both triangles. So I know that angle V is congruent to angle V because it's the same angle. In both triangles. Now I need to test the matching sides. So shorter over shorter, longer over longer. Shorter, shorter, longer, longer. So shorter side over shorter side, 8 over 12. They can both be divided by 4. That gives me 2/3. Longer side over longer side, 10 over 15. Those can both be divided by 5. That gives me 2/3. So since both fractions simplify to the same thing, and the angle between the two sides is the same, I have side angle side. So I can go ahead and name the triangles. Triangle WVZ is similar to triangle XVY by side angle side. Okay. Let's look at one more example here. So I see two sides on both triangles. The third side is not labeled, so do I have any angles? Always check to see if you've got either an overlapping angle or vertical angles. If you see an X, you have vertical angles right here. So if you look at it, you now have side, angle, side. So as we go through this, I want to name the angles that are congruent, and because I can't name them both angle K, I'm going to need to name them with 3 letters. So the one on top will be angle LKM. Is congruent to angle GKH or HKG, doesn't matter with the angles, what order they're named in. So I want to make sure that I get the sides in the right fractions. So I'm going to do longer side, and shorter side, shorter side. Make sure that the fractions have the correct pieces. So if I do shorter side over shorter side, 3 over 12 is 1/4. And I did the bottom triangle on top. I don't know why, but I need to make sure I do the same thing on the other triangle. So the other triangle, 5 over 16, well, that doesn't simplify. Those are not the same. So because they are not the same, these two triangles are not similar. So if they're not similar, don't write a similarity statement. I know that when you see a whole bunch of writing that you want to just skip over it. But I have written you a list of steps here, and if you follow this list of steps, it will really help you to figure out how to do the problems on your homework. So the first thing you should do when you see a triangle similarity problem is look at the diagram and figure out whether it's telling you about sides or angles or both. So are all the things that are labeled sides, are all the things that are labeled angles? Does it tell you about both sides and angles? And if you've got those overlapping triangles, draw them separately. Now, you may have some angles that you know are congruent that are not marked on the diagram. So you want to figure out if you've got any of those. So the reasons you want to look for that tell you you've got congruent angles are overlapping angles. If you've got the same angle that's part of both triangles, that angle up there would be the same in both triangles. Vertical angles across from each other in an X. Anytime you see that, they're congruent. If you were told how big two of the angles are in a triangle, you can always figure out how big the third one is. Add the two you know, subtract the answer from 180, and you do need to show your work. The last thing is something that you may need to go back to section 9.2 if you haven't yet and review. And that is if you've got parallel lines or segments and something that goes across like this, if you've got these two angles, those would be alternate interior angles, and they are congruent. Or if you have this angle and this angle, those are congruent. Those are called corresponding angles. Now the thing is that you may not have those lines extending out forever. You may just have part of this diagram, but you want to watch for those. So once you find any angles that are congruent, write down your congruency statements and then decide what test to use. If you now have two sets of congruent angles, use angle, angle. If all you know about are sides, use side, side, side. If you know about two sides and the angle between them, use side, angle, side. If your test involves sides, you need to make fractions out of matching sides. So make sure that you are using matching sets of sides. Shortest over shortest, middle over middle, longest over longest. And make sure that the same triangle goes on top in each fraction. So if all of your fractions simplify to the same thing, then you have proportional sides. If they don't, they're not similar. So once you figure out whether the triangles are similar, you can write your similarity statement. If not, you write not similar. So on your homework, you're going to be asked to do 4 things. The first thing is to list any congruent angles and say why they're congruent. The second thing is to decide whether you have proportional sides and show by checking their ratios. So simplify some fractions. The next thing is you're going to say which test you're going to use. And the last thing is you're going to write a similarity statement or write not similar. So let's start with this first one here. So when you see overlapping triangles, first draw them separately. So I've drawn my two triangles separately. Now I'm going to label all the information that it told me about them. So first of all, I know that on the smaller triangle, this side up on top, side DM has a length of 50. And on the larger triangle, side DC has a length of 70. And on the larger triangle, the long side is 42. Well, I don't know, this 12 is only a piece, but if this whole side is 42 and this piece is 12, I can do 42 minus 12 to get this other piece here. So 42 minus 12 will tell me what DL is. So 42 minus 12 gives me 30. So this is 30 right here. So I've got two sides. Now I don't know how long this side or this side is, so I can't use side, side, side. Do I know any angles? Well, they're overlapping triangles. I know that the angle that overlaps in the two is the same in both triangles. So now I'm going to make a list of everything I know. So angle 1 said list any pairs of congruent angles and say how you know. Okay. Angle D is congruent to angle D. It's the same angle in both triangles. All right, number 2 says determine whether the corresponding sides are proportional. So I am going to do shorter side over shorter side. So 30 over 42. Those can both be divided by 6. That gives me 5/7. And longer side over longer side. 50 divided by 70. That gives me 5/7. Okay, so decide what test to use. Well, what did I have here? I had side, angle, side. Side, angle, side. So I used SAS. And then it said, if they are similar, complete the similarity statement. So triangle DCB across the green and then the uncolored. So DCB is similar to triangle DML. Go the same direction. I need to see all of that on your paper on the homework or you're not going to get any credit. If this is all you do, I'm not even going to grade it. I need to see everything here in order for you to get credit. Let's look at another one. So the first thing that jumps out at me is none of the angles are labeled. So because I don't have any information about how big any of the angles are, I don't know whether J and any of these are the same. I don't know any information about how big J, K, L, A, B, or C are. This must be side, side, side. All of these numbers out here are side lengths. So I don't know anything about the angles. So I don't know any information about angle measurements. So I'm going to test the side lengths. So let's start with shortest over shortest. 15 over 35. Those can be divided by 5, and that gives me 3/7. Middle over middle. 25 over 56. That doesn't simplify, but it's not 3/7. And longest over longest. 27 over 63. Those can be divided by 9. And that gives me 3/7. So this is kind of interesting because 2 of them simplify to the same thing, but the third one does not. I want to show you that 25/56 does not simplify to 3/7. Doesn't simplify. 25/56 does not simplify. You could compare the decimals if you wanted to. 3/7 as a decimal is about 0.429. 25/56 is about 0.446. So these are different decimals. So they all 3 have to be the same. Okay, well, what tests did we use? All of these were sides. Side, side, side. Side, side, side. So we used SSS. And down here, don't fill in the similarity statement down here. It says triangle ABC is similar to. Well, it's not similar to anything. We just showed that it's not similar. So write not similar instead of filling it in. Last one on here. Ooh, this one's tricky because I don't see any numbers. So that means there must be some things we're looking for with some congruent angles. So first of all, I see an X. So there's some vertical angles right there. So I need to name them with 3 letters. They can't both be angle F. So angle CFB is congruent to angle GFH. Now I need a second set. So for this, you need to remember or go back and review the information for section 9.2. So in order to help you see this, I am going to do this. You have 2 parallel lines and a transversal. This angle right here and this angle right here are both between the 2 lines, so they are interior angles. Interior means between the lines. This one is on the left of the transversal, and this one's on the right of the transversal. This is the transversal, the one that cuts through the 2 lines. So if one is on one side and one's on the other side, they're called alternate interior angles. And there's a theorem that says if you've got parallel, that's what the 2 arrows mean, parallel lines, then alternate interior angles are congruent to each other. So angle B is congruent to angle G. And we were supposed to say Y. So these were vertical. These were alternate interior. Now, just to point out, if you look at this, there's another transversal cutting parallel lines. This right here and this right here are another set of alternate interior angles. Now, you didn't need all three, but you could have had all three if you wanted to. So I'll put those in a different color. Angle C is congruent to angle H, also alternate interior. Go review 9.2 if you don't remember what that means. So look, I've got 3 sets of congruent angles. Again, you only needed 2 of them. Question 2, I don't have any sides that I have information about, so none to look at here. Question 3, well, what test should I use? Well, all the information I have is about angles. So this is angle, angle. Now I need to name this. So FGH, blue, red, green, is similar to triangle FBC. So those are the notes. I know that's a lot. I am actually going to make another video with some more example problems because people tend to get really confused on the homework for this section. Please just make sure that you're doing all 4 things on each one. List the angles, tell me how you know, tell me about the sides, simplify your fractions, and yes, I do need to see the original fraction and the simplified one. Tell me which test it is, write either the similarity statement or write not similar. So I need to see all of this in order for you to get credit on the front of the homework.